Hey everyone, it's Justin again. In this video, we're going to be visualizing systems of equations and their solutions using graphs. We'll be graphing a lot in the next few videos, so make sure to have some graph paper available. So we've previously learned how equations can be graphed from a variety of formats. For instance, this slope-intercept form equation could be graphed by plotting the y-intercept, then applying the slope from that point. This line we've graphed passes through every point that serves as a solution to the equation. The point 1, 2 works as a solution, because if we plug in 1 for x and 2 for y, the equation is true. And as we learned in the previous video, a system of equations is multiple equations sharing the same variables. By adding a second equation with x and y variables, we now have a system of equations. As you can see, the equations don't have to be in the same form because all forms can be graphed. All points on this orange line are solutions to that orange equation. When solving systems of equations, you are looking for a solution that works for both equations. So what would that look like on the graph? We need a point that's on both equations. So the solution is the point where the lines overlap or intersect. Remember, checking a solution is easy. Plug into both equations and just see if they're true. So to recap, before we do more examples, when graphing equations, the solution is wherever all the lines intersect. If we want to solve this system of equations, first we have to graph the blue equation and then the orange equation. If you need a refresher on graphing different forms of equations, you can refer back to those videos in Unit 5. The solution is going to be any point where the lines intersect, so the solution to this system is -3, 2. Let's try a larger system. What changes if our system has 3 equations? The goal is still the same, find where they intersect. So we graph the blue equation, the orange equation, and the green equation, and then we find where they intersect. So -2, -5 is the solution. Well, no, wait, it's a solution for blue and orange, but not green. So it doesn't work for the whole system. Okay, then the solution is 0, 1. Oh, no, but that isn't on the orange line. We might as well rule out 2, 1 also because it's not a solution for blue. So what's the solution here? Well, if there are no points where the entire system intersects at the same time, then there's just no solution. The more equations there are in a system, the harder it is to find a solution, but that doesn't mean bigger systems can't have a solution. Even a system with a lot of equations can still have a solution as long as they all intersect. If we graph these lines, we see that all 5 of them intersect at the point -1, -2. Graphing can be an easy way to solve a system of equations, but we'll also learn 2 other methods later on, in case graphing doesn't work well for you. In the next video, we'll talk some more about those weird results that you might get when you're solving systems of equations, like that example that had no solutions. See you next time.